Hi, Assalamualaikum. We are from Group 2, Engineering Mechanic Labs 2, Section 3. Are going to present the Lab 9, rolling this on an inclined plane. My name is Muhammad Tariq Nazmi bin Abdul Rahman, and my other teammate Shamirul Fahmi bin Shamsuddin, Muhammad Azmal Isham bin Zamri, Tiniswa anak lelaki Jagannath Pillai, and Najiah binti Abdul Rahman. And not to forget our lecturer, Sir Zulhelmi bin Ismail. Okay, first of all is a lab objective. The first one, we are able to understand the mass moment of inertia by these two experiments, that is, rolling experiment and the pendulum experiment. The second objective is to determine the law of falling bodies on an inclined plane. Move to the introduction. Free fall. Okay, what is a free fall? A free falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of a free fall. Okay, there are two important motion characteristics that are true of free falling objects. The first one is a free falling object do not encounter air resistance, and the second one, all free falling object that is on Earth accelerate downwards at a rate of 9.8 meter per second square. Next, a moment of inertia. A measure of an object's resistance to change in rotation direction. A moment of inertia has the same relationship to angular acceleration as mass has to linear acceleration. The example that we can see the moment of inertia is at the simple pendulum. Because the simple pendulum has the resistance to the rotation caused by gravity. Mathematically, the moment of inertia of the pendulum is the ratio of the torque due to gravity about the pivot of a pendulum to its angular acceleration about the pivot point. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Shamirul Fahmi bin Shamsuddin and my metric number is MA19035. Today I will be presenting about experiment setup and result. Okay, for experiment setup in lab, we use TMC11 rolling disc on inclined plane. This we can see this picture. We use this setup in lab. We also use a stopwatch. Okay, because of COVID-19, we need to do a custom made rolling disc on inclined plane to make an experiment setup at home. So we use a metal rod for marking purpose and serve as roll instrument in the apparatus. And then B, rolling a ruler to measure the height of the plane inclination. C, GPU stand used for height adjuster to adjust the angle. And D, scissor to cut the box. And E, container lid with different size and weight. And F, protector to measure the angle. We also use smartphone stopwatch application. Okay, for experiment procedure in home, we choose test one inclined plane. Okay, first step, we use the measuring tape, select the desired distance. The board used in this experiment is 500 mm and cut the board like the picture below. And then the second step is set up the box and use GPU stand to become a higher adjuster of the inclined plane. Also, to adjust the desired inclination, use the protector. Okay, the third step, by using a metal rod, two containers lid with different size, construct a custom made two discs. Make a hole at the middle for each container. That metal rod will serve as a roll instrument on the custom made carrier. Okay, fourth step is position the custom made disc on the carrier as shown in the figure below, like this. And then place the custom made disc at the zero position on the track. Make sure the midpoint of the rotational axis is located at the marking, and the custom made disc is positioned in the center. Okay, sixth step is Let the custom-made disk go and start the smartphone stopwatch application. And then on the desired distance, stop the watch and the disk. Make sure the watch is only stopped when the bit of the point has reached the measurement mark. Step 7. Repeat the measurement procedure several times to minimize measurement error. Then calculate a mean value for each series of experiments and put the results in table 1, 2, and 3. Okay, this is formula that we use. So the first formula we use is acceleration, and then J is mass moment of inertia, and also T is the time. So we use the formula and calculate to get the result for table 2 and 3. Okay, this is the result that for table 1. We can see the inclination is increased 1 degree, and then we get the time for time 1, time 2, time 3, and then calculate to become to get the time mean for a larger container lid, and also for small container lid. And then for the table 2 is for a larger container lid, roll time a distance of 500 millimeter. Okay, with the result time that we get before this, we use the formula of acceleration to calculate it. So this is the result for acceleration for every inch of uh, angle. And for calculated time, we use the formula of T before this. And then for deviation, we use the formula calculated time minus by measured time divided by calculated time. And then we get the result 31.6% for each angle. And for table 3 is the same. Use the formula that we get, and we calculate and we get the acceleration and also the calculated time, and then deviation using a formula calculated time minus by measured time divided by calculated time. So that's all for the result. I think that's all for me. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Azmani Syamil Zamri. My ID number is MA19136. Okay, I will continue with the discussion part. The first question is how to adjust the angle of inclination. To adjust the angle of inclination, we should turn the height of adjuster spindle until the desired value shown by the angulometer. And the second question is what is the purpose of angulometer? Angulometer is a device to measure the external angles. In this experiment, it is used for measuring the angle of inclination. Okay, let's move to the next question. Can you give an alternative method to measure the angle of inclination? Okay, to answer this question is an alternative method to measure the angle of inclination is by using trigonometry method. You can see, you can review the formula in the below diagram. And the fourth question is how to make a precise alignment for this experiment. In order to make a precise alignment for this experiment, you must turn the height of the adjuster spindle to make sure the three bubble level is exactly in the middle. And for the fifth question is why the angle higher than 7 degrees cannot be used for this experiment. Okay, because the error of measurement will highly occur if the angle higher than 7 degrees is used. Specifically, the disc will be rolling with high speed and the time taken for it to arrive at the end of the plane will be really short. Thus, the experimental results will be affected. That's all.
Assalamualaikum warahmatullahi wabarakatuh, and good day to our lecturer Dr. Zulhelmi bin Ismail. My name is Najiha binti Abdul Rahman. I'm from group number 2. Today I will present about a discussion from number 6 until number 10 in lab number 9, which is rolling disc on an inclined plane. For number 6, give the definition of free fall theory which discovered by Galileo. On the basis of the law of parabolic fall, Galileo reached the conclusion that bodies fall on the surface of the earth at a constant acceleration, and that the force of gravity, which causes all bodies to move downward, is a constant force. In other words, a constant force does not lead to constant speed but to constant acceleration. Number 7. Give the factors that cause free falling body. The factors that cause free falling body is gravity. The force of gravity causes objects to fall towards the center of Earth. The acceleration of free falling object is therefore called the acceleration due to gravity. The acceleration due to gravity is constant, which means we can apply the kinematic equation to any falling object where air resistance and friction are negligible. Number 8. What is the relation between angle of inclination and the rolling disc? If the angle of an inclination with the horizontal is small, a disc that rolling down the incline moves slowly and can be easily timed. Using time and distance data, it is possible to calculate the acceleration of the disc. Hence, the relation shows when the angle of the incline is increased, the acceleration also increases. Number 9. Explain the term inertia. Inertia is the property of an object to resist any change in its state of motion or rest, including changes to its speed and direction. Number 10. Why repeatability of the measurement is important? Measurement repeatability is the most important parameter of any measuring process. Without good repeatability from the measuring system, the collected data is of no value. Crucially, measurement repeatability plays a key role in determining product reliability. If a repeatability process is fluid or metrology tools don't have good repeatability, the true result will be affected. That's all from me. Thank you, Doctor, for listening.
Hello, sir. My name is Sinishul, son of Jaya Reply. My thematic number is MA19217. I'm here to explain about the discussion from number 11 to number 13 and the conclusion of the experiment. Okay, let's see the number 11 question, which is draw the free body diagram of the disk roll on the inclined plane. This is the free body diagram that we draw. Uh, This is the disk rolling on the inclined plane. The weight is acting downwards as the gravitational energy. Okay, next. Number 12. Why the deviation occurs between calculated and measured value? This is because deviation occurs between calculated and measured value because of some measurement errors. For instance, there is a possibility of parallax error to be occur, which means the observer's eye is not squarely aligned with the pointer and the scale. This leads to the reading to be too high or low. Other than that, it could be because of equipment errors which influence of the disk as it has conical shaft generators. Next, number 13, suggest improvement of the experiment. The experiment should be carried out in a vacuum place to avoid the air resistance from interfering the experiment result. The experiment should be repeated several times in order to determine the true machine value to improve the result of the experiment. Repetition of the experiment will reduce the error and the carried out experiment in a flat surface. Okay, finally, let's see conclusion of the experiment. In conclusion, the experimental angular acceleration of the rolling disk can be calculated from the summation of minutes using mass minute of inertia. From simplified kinematic equation, the hypothetical precise speeding up was calculated from the comes about of the experiment where the disk begins from the rest. The major mistakes are caused from the incorrect selection of the beginning point of roll and the frictional impacts of the contact points. From the experiment, we do know that the precise speeding up is steady and precise speed keep increasing as the disk rolls down. Thus, the relationship between mass minute of inertia and angular speeding up and precise speeding is effectively decided in this right in case error source is neglected. Other than that, the value of the moment inertia is different uses. The acceleration of the disk rolling on an inclined plane is influenced by the mass and the diameter of the disk. Okay, that's all from me. Thank you.